Hello, everyone. My name is Brenda, and I think I might have talked to some of you in the past, but it's really great to be here. And yeah, today I'll be talking about Boost and some of the retrievals tooling updates that we have recently. So please feel free to ask questions. Um, and yeah, we'll dive right in. Oops. So first of all, I'm really excited to share that we've recently launched Boost V2. And the biggest update with Boost V2 is that we're introducing this local index directory, which essentially, we'll dive into a bit more, but it's going to really help with scaling up SP operations. So if you're trying to grow your SP operation, you're trying to onboard more data, this will really help with that. So look forward to it. And I also wanted to highlight, this neat translation tool. Also wanted to highlight some of the features that we're working on. So one of the feedback that we got was that the local index directory would be great if it could scale to multiple Boost instances. So you can only have one local index directory that manages the indices for the different Boost instances that you're running. So that's coming up soon. We also have a PSD manager, which will basically help you manually manage and send your PSD messages. And then last but not least, we have some performance enhancements coming, which will help with retrieval latency. All right, so I wanted to talk quickly about the history of motivation behind the local index directory. And a lot of it was actually based off of the DAG store, because the DAG store was the original tool that we're using to design and store local indexes. And some of the problems that a lot of storage providers had actually told us was that it's causing a lot of issues. And sometimes it wasn't really working properly, or the DAG store would get in a corrupted state. So the main thing there being it's not that scalable. It's like a single process. And there's some retrieval reliability issues. And so if we want to actually be able to onboard more data for clients, we'd have to basically take steps to scale out Boost. So that was kind of the first step that we took with the local index directory. And so quickly, what exactly is the local index directory? You might be wondering. It really is just a backend that manages and stores indexes of deal data for you. And it replaces the DAG store with this horizontally scalable database. So the database that we're using is called Yugabyte DB. And essentially what's being stored in here is when you can look at the diagrams on the right, but essentially you see what happens when someone is trying to store data or retrieve data. You have to store information about the CID and kind of the offset within a particular piece in that deal data piece. You also have to store information about the sector that the piece is in. So when the retrieval request comes, you know where to go look in your ceiling subsystem to pull out this data. So yeah, some neat diagrams here that kind of walk through the process. Let me know if you have questions. And yeah, I wanted to share also some of the benefits that local index directory will have to storage providers. So one of the biggest benefits here is that you no longer need to rely on the DAG store. And so I don't know how many of you ran into bugs here, but there were a bunch of issues that were reported. And so we went and set out to fix all of these in the local index directory. So you should have a much better experience there. And then second, we also added tooling to help SPs see more information in terms of storage health. So you can, there's a screenshot on the right of kind of a UI page. That way you can see the current state of all your sectors and indexes. It also flags pieces for you that need reindexing or unsealing in case you're running into some retrieval issues. So that's that. And then next, there's improved coordination between Lotus and Boost. So if you haven't heard yet, Lotus Miner is undergoing a re-architecture, and they're going to be storing some data into the Yugabyte DB as well. So that's going to be a lot more helpful. There's also an out-of-the-box management experience for Yugabyte DB that folks can use. And so, yeah, we really hope that the local index directory will help with just broader SP operations. So, and then the last point here is that we want to enable horizontal scalability for storage providers that are storing client data. So as folks in DSPA start working with more clients and start onboarding client data, we want to make sure that Boost doesn't become a bottleneck for data onboarding. So that's kind of another one of the motivations here. And then I did want to talk quickly about migrating to Boost v2. For those of you that might be on Boost already, it is a bit more involved compared to what you might have experienced in the past with Boost upgrades. So just wanted to make sure the expectation is there. It will take more time and energy to do this upgrade. So the first step being, like, before you even do the upgrade, you have to download and set up Yugabyte. And so because we're changing how you kind of connect to this local index store, please dedicate time to understand Yugabyte. And when you do the Yugabyte setup, there's like infrastructure implications. So please go through the documentation and understand the Yugabyte setup before you just like kind of do the migration process. So that's the first step, download and set up Yugabyte. And then the second step will be to update to the latest version of Boost v2. So that's, I think, what folks should be familiar with. And then after that, you follow some instructions to run migration. And we have a migration tool that you can use. And the neat thing here is that the tool will actually run the migration in the background, and you could start and stop it at your convenience. So you don't need to, block off operations when you're running the migration. It'll happen in the background. And if you happen to need to pause it in the middle, it's very doable, and it'll restart whenever you need to start back up again. Last but not least, once you're done with the migration, there's a piece doctor in the Boost UI, which will fix any flag sectors for you. And I've included a link to the migration instructions there. All right, so that was just a really quick overview of some of the changes we made with local index directory in Boost v2. And that's kind of one of the steps that helps the retrieval process run more reliably. And now I'll talk a bit about serving retrievals in Boost. So hope some of you have tried it out, but we actually have a number of different retrieval tooling available. So first of all, why do retrievals even matter? Like, why is it important to do this, right? And here we kind of see that there's this golden path for users when they interact with the Filecoin and IPFS ecosystem. So basically, in this nifty diagram here, you can see that, hey, as a user, which is depicted by this Filecoin dog, the user will go and want to store data in this ecosystem and wants to be able to retrieve it back. And so we want to basically facilitate more usage in this ecosystem, so there's more value that people get from Filecoin and IPFS. So now I will do a quick walkthrough of boosting your retrievals. This is actually the same diagram that you saw earlier about the retrieval process. So you can see here that the retrieval client will request a CID from Boost, and then Boost actually will go to the local index directory to get information about this particular CID in their ceiling subsystem. So it will be like, what sector is this CID in? What's the offset within the sector? And then it can go and grab that data directly from Lotus. All right, so first I wanted to cover retrievals over GraphSync. These retrievals are built into Boost by default and part of the Boost daemon. So when you run Boost, you will get GraphSync retrievals by default, and it's currently the primary way of making storage deals on the Filecoin network and retrieving deals from Filecoin nodes. GraphSync is a type of data transfer protocol. So next, after GraphSync retrievals, we've introduced piece retrievals over HTTP. And so we added a new Boost process called Booster HTTP. This was introduced in version 1.2. And the main goal of serving piece retrievals is to make it easier for storage providers to replicate content. So this is basically when you're trying to replicate a storage deal, you can basically grab that particular piece from whichever storage provider had it, and then make a deal yourself with that type of data. And you can see there's a link here that is being formalized as part of a fifth discussion. All right, so after we added Booster HTTP, we added Booster Bitswap, and this is also a new process in Boost. And with Booster Bitswap, you can basically serve any chunks of files over the Bitswap protocol. And the main benefit of enabling Bitswap-based retrievals is that it was the first step to kind of bridge the gap and close like Filecoin and IPFS interoperability. So if you see in this like diagram down here, there's like, these blue circles that represent Filecoin storage provider nodes. There's also these like light blue boxes, which represent IPFS nodes. And the neat thing here is that, you might have a retrieval client, Lassie, for example, and it'll go look for content in the network indexer. So this middle hexagon thing kind of represents the interplanetary network indexer, also abbreviated IPNI. It'll go and you can basically either retrieve from Filecoin or IPFS. And because we enabled Booster Bitswap, you can actually retrieve from Filecoin via Bitswap, which is really neat. And then last but not least, we've added retrievals over HTTP. So essentially, we've added an HTTP gateway functionality to Booster HTTP in version 1.7. And here you can basically serve any chunks of files over HTTP, and this enables more interoperability with the rest of the web. So there's a link there for folks who want to go see it, but it's pretty neat. You can basically interact with Booster HTTP like an IPFS gateway, and you can see like your different file breakdown, and you can click into individual files, and it's quite neat. I don't think this video will work. That's okay. And I wanted to cover quickly the focus on HTTP for the next few minutes. Yeah, just a quick overview of the different HTTP-based retrieval options that we have. You can retrieve a full piece. And what's the use case you might think for retrieving a full piece? As I mentioned earlier, it's helpful for creating a replica without worrying about basically creating identical column P. And it can also be used when the piece isn't a car file even. So just for convenience in replicating deals. Next, you can also retrieve a range of a piece. So this is helpful if your client or maybe you as a storage provider have maintained an index of your own data offsets. You can go and retrieve directly a range. You can retrieve a full car file. You can retrieve by block. You can retrieve the original file by CID. And this includes padding. So if you have like a file directory structure, you can retrieve individual files. And basically the neat thing here is that as a storage provider, you can serve data through a browsable IPFS gateway web interface. There is a note of caution here. If you enable this mode, you want to be careful. Your domain, depending on, the interwebs and how they manage and look at content, I guess, censoring here. There could have been instances where IPFS gateways have been blocked, so just be aware when you enable this mode. So you might wonder, like, why choose HTTP as the, I guess, like main data transfer protocol for retrievals? So first thing really is HTTP is a battle tested, and it's been around for a long time, and people know how to use it. So right, it's HTTP is really battle tested and ideally optimal path to serve retrievals at scale. There's lots of great tooling available listed here that you can use automatically and set up as part of your operation. And last but not least, a number of storage providers have asked to have HTTP be a supported data transfer protocol versus just GraphSync or BitSwap. So what's next for Boost Retrieval? So as I mentioned in the very beginning, we're working on performance improvements here, and we're also working on some automation tooling to set up some good default configurations for Boost that will enable you to leverage these latest features. There's also a project called Project Rhea that's going to be launched in the near future, and this will add a good amount of retrieval traffic to storage providers. We want to make sure that we're prepared for that. And then for the Fill Plus program is going to start checking HTTP retrievability for approved data sets. So want to make sure folks are aware of these. And so one of the things that we're trying to encourage here is that we're encouraging storage providers to use HTTP retrievals by default to help the network scale. And please let us know how we can help you get there. That is the end of my presentation. Thank you so much for having me. I will stay online to answer any questions. Feel free to ask in English or Mandarin. I can speak Mandarin, but it's not as great as my English. So thank you very much, everyone.